Okay, 8.4, sample problems. Let's start with number 4. And as we begin these problems, remember what I said, that the most important thing that you're going to need to have a strong grasp of is how to simplify these rational expressions, or how to cancel stuff out. Okay, so I'll do my best to keep reminding you how to do that correctly. We have x squared plus 9x plus 14. Okay, so this gives you basically multiple choice. It wants you to figure out which of A, B, or C is the simplified form of this. Okay. Now, let's go over what you shouldn't do, should not do. This. You think you see x squared and x squared, you should cancel them out because they're the same, and now you're left with negative 4 over 9x plus 14. As we ease into this, it's helpful that that's not a choice. Negative 4 over 9x plus 14 is not a choice in A, B, or C. So why shouldn't we do that? Well, let's remind ourselves, if we don't remember, why do we cancel something between 6 and 15? What do we cancel between 6 and 15 when we cancel? Well, we look at them as, oh, this is 3 times 2, this is 3 times 5, so they have a common factor of 3, so this is 2 over 5. And that's right, because it's a factor, okay? X squared is not a factor of the numerator, like 3 was a factor of 6, the numerator. If we want to see what the factors are, we have to factor it first. It's not factored yet. This is just a polynomial, and it is unfactored, okay? So in order to cancel some common factors, it first has to be factored, and then we can cancel common factors. So let's get rid of this. Alright, so let's factor the numerator. That's going to be x plus 2 times x minus 2 over, and we're going to factor this guy here, and x. Two numbers that multiply to 14, probably 7 and 2, right? I don't know of any other ways to do it. And just quickly, my eyeball shot over here to 9, and I confirmed that it did add to 9. Okay, so this is factored. X plus 7 times x plus 2, this is factored. X plus 2 times x minus 2, that's factored. They're multiplied together. This is a factor. This is a factor. This is a factor. This is a factor. Now we can cancel any common factors that we see. And those are common. So we get x minus 2 over x minus 7, and that is, x plus 7. That is A for number 4. Okay? So at some point, all of these problems are going to come down to, did you cancel correctly? Because if you're honest with yourself, multiplying these things out is not the most challenging thing. We've been doing it for such a long time. But it will prove a challenge to cancel correctly. But if you just remember, you can cancel common factors and just ask yourself, am I looking at factors yet? Okay? If you're trying to cancel stuff out, ask yourself, are those factors? Are they multiplied? Okay, and in this case, in the very beginning we just talked about, no, they were not factors. We had to factor them first. So now we factor them, and then we can cancel common factors. Okay? So remember to ask yourself that as we move on to number 6. 4x squared over 20x squared minus 12x. Alright? Can we factor this? Not really. It's factored. It's 4 times x squared. 4 times x squared. There's only multiplication going on, and there's nothing to really factor. Okay? But here, we could factor this. We could factor out first. What we always do with any polynomial when we factor is look for the common factor among all of the terms. We've got 2 terms here. Do we have any common factors? 20 and 12 both have a factor of 4. I believe that's going to be the biggest one, 4. Also, they have a common factor of x. So we're left with 5x minus 3. All right. Well, look there, we have a common factor of 4 here, right? Because it's 4 times x squared. This is 4 times x times 5x minus 3. This is a factor here. So 4 is a factor of the entire numerator. It's a factor of the entire denominator. Just multiplication makes up this entire denominator, right? Once we start adding stuff on, now we know we have an issue. And we need a factor. So what else is in common? What common factors do we have? We have a factor of x in common. That'll take out one of those x's. Okay, so we'll be left with an x in the numerator. The 4 and the x both got canceled, and now we have 5x minus 3. And now you'll want to maybe cross out this x. You'll go cancel crazy. But remember that x is not a factor of the denominator. X is a factor of 5x, but it's not a factor of 5x minus 3. It needs to be a factor of the entire denominator. Okay? So unless your denominator and your numerator are factored completely, and you can find an exact match between factors, you can't cancel. And there's no exact match between factors here. This is the whole thing right here is the only factor of the denominator, and x is the only factor of the numerator. No canceling happening. Number 12, x minus 4 over x cubed minus 64. Okay. Well, x minus 4 is not going to be factored in any way. It's not factorable. You can't factor out a common factor. You can't factor it at all. I don't know how many times I can say the same thing. X cubed minus 64. How do you factor that? First, you see that it is cubed. That should really, set off a alarm in your head, because most of the time they'll be squared, right? The typical appearance of these things is squared, and a lot of times we'll just we'll throw 2 parentheses up like we did up here, and factor into 2 parentheses. But this is x cubed, and so it's very different. And that cube should, after a while, when you've been looking at these polynomials for a while, make you think, difference of cubes or sum of cubes. You ask yourself that, and it would be a difference because it's subtraction. And now you just need to figure out, is this a perfect cube? This is. X cubed is of course a perfect cube. Is this a perfect cube? Is this something cubed? This is x cubed, and this is indeed 4 cubed. Alright, so at this point, I would say you might go into the glossary, or not the glossary, but the index, and find, hold on just a second. Yes, well, of course you didn't wind up holding on at all, but I did freeze the recording of this video and confirm that if you go into the index of this book that we are using in Mr. Stewart's class, you do go back to the index and look under difference, and right under there you see of 2 cubes, and there's a page number that goes along with that, and you go look up how does this factor. Okay, and I've done this so many times, it just never leaves you at some point. Okay, so you just take the first thing that's being cubed minus the second thing's being cubed, and the first thing that is getting cubed, which is x, you square that, plus the 4 times the x, plus this guy here that's being cubed, the number 4, you take that and square it, and that's where you get 16. So now what we find is a common factor of x minus 4. This is the factor of the numerator. It's the only factor. And here is a factor of the denominator. It is x minus 4 times this guy here makes up the denominator. So this is a factor. And this is the other factor. Now we're left with 1 over x squared plus 4x plus 16. Okay? Pretty straightforward. Now we'll do a multiplication problem at number 24. Okay, thanks for watching me write that. We're going to multiply these two together, which means straight across. Multiply straight across. Multiply this guy by this guy. The two numerators times each other, and the denominators times each other. All right. So let's do this a few times. We can do it a few different ways. We could just multiply straight across, which means we'll get 5x cubed. And now we're going to multiply y's together. We got a first and a third, so y to the fourth is the result. We add those exponents. Okay, now we get 15. I like to put the number first. We got x squared times x squared is x to the fourth. And now we have y squared. And now we can cancel stuff. Y squared will cancel with two of those. That'll leave a y squared. X to the third can cancel with 3 of those factors of x down in the denominator. 5 can cancel with 15. We're left with 3. So we get 1 times y squared over 3 times, we got a factor of x left down here, and no factors of y are left, so y squared over 3x. Okay, that's not bad. You know, that was plenty easy. We could do this too. We could come back to the beginning, and before we even start, like I'm seeing this y and this y squared, y could cancel with one of those there. You're left with a factor of y. And x squared could cancel with 2 of those factors of x. And then you know what's going to happen is we're going to multiply straight across, and so everything's going to be multiplied together in the numerator and denominator. So all of the factors are going to be, joined together. So the factors that are over here are going to wind up being able to cancel with any factors that are possible over here. So that's where we get the idea of cross-canceling. We say they're going to wind up having the factors, all these factors are going to be together in the numerator, all these factors are going to be together in the denominator, so we could just factor across before we even multiply. So now we have a factor of y. Remember, we already canceled one of those factors. So we got a factor of y here, and we could cancel one of those, and we're left with a y squared. We could cancel this x that's left with one of those factors of x. Cancel this 15 with this 5, leaving a 3. Okay, we got nothing in the number department here. We got no x's left. We got no y left. We got a y squared here, though. Nothing but 3 and x. Okay, it's up to you how you want to organize this. This could get totally messy and confusing. Maybe it does look messy and confusing to you. Make sure it doesn't look messy and confusing as you go from your crossed out form to your cleaned up form. Don't miss any factors. All right. So just a piece of advice there. Number 27. 4 times x plus 5 x squared x times x plus 1 over 2 times x plus 5. Now, I know that a lot of students will be tempted to distribute this 4, distribute this x, distribute this 2, because it just feels like the thing to do. Just multiply it out. But remember, we can cancel common factors. We can cancel common factors. And are we looking at factors yet? We already are. They are factored. So we don't want to mess with that. If we distribute, what we are doing is unfactoring, right? That's the reverse of factoring, is to distribute something through another parentheses. So let's leave it factored and cancel common factors. And let's just cross-cancel now that we know we can. And we have a factor of x plus 5. It is a factor. Got to confirm it's a factor. These both have factors of x plus 5. That's great. Factor of 2, that leaves still a factor of 2 here. We got a factor of x and one of those factors of x. And sometimes there's just been so much canceling. Let's just write it down again just to make sure that we got everything. Maybe we'll cancel again and it'll be fine. We got 2 here. Nothing else is left. No x. X plus 1 is a factor that's left. I got a factor of x down here, and nothing else. This got canceled, this got canceled. So 2 times x plus 1 over x. And of course, we are no longer fooled by trying to cancel this x here, because that is not a factor. Not even close. Okay, so don't do that. Good job. You're doing great. 34. Okay, there's 34. And before we do anything, absolutely before we do anything at all, we should recognize we have a division problem here, and it's just messy. When you're dividing by fractions, it's just a messy thing. So let's not divide by a fraction, and let's remember that it's the same as multiplying by the reciprocal of this fraction here. Okay, so we'll rewrite that. Y to the third over 30xy to the fourth. Okay, now that's good. It's like, I don't know, just don't deal with division. I was trying to think of an analogy, couldn't come up with the one on the spot. Just don't even begin to think about how do we multiply these, can we cancel stuff out. Don't do that until you have removed division from the problem and have made it multiplication. Now we're ready to go. Now we can go ahead and say, can we cancel anything? But we've got a factor of 5 here and a factor of 5 here, leaving 6. Let's move on here. We got x squared, and we got 2 factors of x here, so we got 7 factors of x, so we can cancel out 2 of those and have 5 left. Okay, and let's start canceling stuff over here. We got 3 factors of y. That'll cancel out one of those factors. Now let's cross cancel if possible. The only thing left up here is y to the third, 3 factors of y, which this one that's left here could cancel with one of those, and we'll be left with 2 factors, and that's it. There's nothing else in the numerator to cancel with anything in the denominator. So now that we've made that look real nice, there's nothing here, nothing there. Y squared, nothing there. Okay, so we got the numerator. We got the number 6 here, then x to the 5th times x to the 5th times x, so that's x to the 6th. And all the factors of y have been canceled out, so we got 6x to the 6th. Nothing left to cancel. Okay. 39 x squared minus 4x minus 5 x plus 5 divided by, here's a crazy one, x squared plus 6x plus 5. Okay, and this could be helpful to remember because we're about to look at the reciprocal, so let's just look at this as a fraction and put that over 1, right? We got a division here, we don't want division, we want multiplication, so let's multiply by the reciprocal. One over x squared plus 6x plus 5. Okay, so not working with division, we refuse to work with division, we're going to work with multiplication only, and now we can think about canceling. But, you know, we say we can cancel common factors, right, all the way back to the beginning here. We can cancel common factors, which begs the question, am I looking at factors yet? And we're not yet. So let's pick a different color here, and let's do some factoring. Alright, let's factor this numerator. Alright, I'm not even looking at this anymore. I'm looking down here. Factoring x squared minus 4x minus 5, putting the x's here, things that multiply to negative 5 add to make negative 4, so how about plus 1 and minus 5, that works. This is factored, this is factored, how about this, we got x and x, numbers that multiply to make 5 and add to make 6, that about 1 and 5, but both positive. Great, okay, so these have been rewritten, we don't have to look at those anymore. If you want to rewrite this, you can. I'm just going to keep working off of what we have. We got a factor of x plus 1 in common, right? And that's it. We'd like to cancel like this x plus 5 and x minus 5. They're so close, but they're just not the same, so we can't cancel them. So we're left with x minus 5 times 1, so that's just x minus 5, over x plus 5 times x plus 5. Or how about x plus 5 squared? Because that's the definition of squared. It's just something times itself. It makes it a little faster to write. And that is the last one. I hope that was helpful. Comment with any questions. Thanks for watching.